In this video, we'll talk a little bit about functions and to finally try to make a relationship among the different types of representations. So really, there are a few different representations. We can use tables to represent functions. We can use graphs to represent functions. We can use ordered pairs, which is really kind of the same thing as tables. But then finally, we can use words to describe functions. So these are the four different ways to represent them. Now, a function has a basic definition. Remember that this just means that an input, can have only one output. Okay, so let's take this situation for example. Well, we have this idea of the vertical line test, which basically we'll use to kind of reinforce this idea of the definition. So the vertical line test basically says that if we were to chop a line going up and down, that's what vertical means, through this set of pairs, then we should intersect that graph at most one place. So for example, if I were to draw a vertical line here, I would only intersect the graph at that point right there. And I could do that anywhere, and we can see pretty quickly that this is in fact a function. So we can represent these three ordered pairs. So really I shouldn't be connecting these dots. I was just trying to illustrate that it doesn't really curve back around. There's no place where your line is going to intersect the graph more than once. Okay, so we really can represent this graphically and see, okay, it does pass the vertical line test. So every input, every one of these ages only has one corresponding hourly wage. So it's as if, imagine that you collect data from your friend, from three of your friends, and you find out that, maybe your cousin who's 10 years old, he doesn't make any hourly wage. So we record this data in a data table just to give that different representation. And then we'll put wage over here as the output. So age is along the input axis, hourly wage is along the output axis. So don't forget that. And so we have an age of 10 goes with a wage of $0. So this person right here doesn't make any money. Of course that makes sense because a 10-year-old cannot be on payroll. And for a 20-year-old, we would have a corresponding wage of $10. And for a 30-year-old, we have, looks like, about a $25 wage. So there's our other representation. Now again, we see that every input, so for example, 10 only has one output. It has a wage of $0. An age of 20 has one wage of $10. Now keep in mind that a function is scenario specific. So in this scenario, we do have a function. Now you might say that not every 20-year-old makes $10, and that's fine, but the data that we have collected does represent a function because each of these ages corresponds with only one wage. In other words, you couldn't link a person who's 20 years old to both a wage of 0 and a wage of 10. And so that's the tabular way we could represent it. In ordered pairs, we would say 10-0, we would say 20-10. Remember, our input always goes first. That's just the format that we have. And then finally, 30-25. So again, we see that an input of 10 only has an output of 0. Okay. And we also said, so we've done tables, graphs, ordered pairs, and in words. So if these two variables are functions, recall that we would say output, this is just the way we always write it, output is a function of input in this scenario. So now let's replace these words because this is always true. This is the way you would always say it if you have a function. This is the mathematical way. So in our scenario, we have, well, what's our output? Well, here's our output. That's hourly wage. Our input is age. So we would say wage is a function of your age. Get some rhyming words there. So our output is a function of input. Okay, so let's abbreviate this a little bit. So with function notation, we are able to abbreviate this by saying, okay, well, let W be our letter representing wage. So every W will have an A. So in other words, with every age, there will be a wage. Okay, so we start off here. We're going to rewrite this statement and we'll say wage. And instead of saying is, in math we write the equal sign.